Welcome back to Edifo. This time, I'm going to demonstrate how we can conduct a one-sample chi-square test. Chi-square test is one of the very popular non-parametric tests in research statistics. It is an inevitable part of many research process. This video explains what is one-sample chi-square test, requirements for one-sample chi-square test, assumptions of one-sample chi-square test, procedure for chi-square test, and last, hypothesis testing with one-sample chi-square test using Microsoft Excel. For understanding one-sample chi-square test, here I am demonstrate an example of brand preference study. What is a brand preference? A brand preference reflects a desire to use a particular company's product or services even when there are equally priced and equally available alternatives. Brand preference indicates a desire to seek out a specific product or service even when it requires paying more or expending more effort to obtain it. In this example, I'm explaining the brand preference towards smartphone brands. Here is our example. When we purchase a mobile phone, we have a brand preference. This brand preference will depend on many factors. There are many smartphone brands available in the world today, but the interest of people with all brands of mobile phone is not the same. We want to test the proportion of consumers' preference, the same for different smartphones. This is our scenario, and this example we are discussing throughout this video for solving the problem using the one-sample chi-square test. For this purpose, we need to select 4 smartphone brands. I have already selected 4 brands for our study. They are Apple, Samsung, Sony, and OnePlus. Next, we need to select a sample from the population. We are going to collect the data from the sample. Here I have selected a sample from the population. Of course, every consumer has their own brand preference towards the smartphone brand. Here we can ask 2 questions. Whether the consumer's preference towards smartphone brands are equal or there is a significant difference. This is our research question. For solving this problem, we can use a one-sample chi-square test. For this purpose, I have developed a questionnaire. This questionnaire is used to collect the data. It includes only one question. Which mobile phone brand do you prefer to buy? Allow the respondent to select only one brand. Here we have 4 brands: Apple, Samsung, Sony, and OnePlus. You can select any one of them. Then next, collect the data. Then we can tabulate the data later in this example in Excel. Now, we move to the next section, that is, what is a chi-square test? Chi-square test has 2 variances, that is one sample and a 2-sample chi-square test. In this video, we are discussing only about one sample chi-square test. Inevitably, I will discuss the other, that is the 2-sample chi-square test, in the next video. One sample means we are only considering one variable under study. Here it is, the mobile phone brand. It may be gender, or it may be educational qualification, or it may be your residential status or your professional status. Anything can be considered as the one preference or one sample. And the symbol that we are representing the chi-square test is this one. This is a symbol that we can represent the chi-square. So chi-square test is also known as Pearson's chi-square test because it is given by the eminent scientist called Pearson and is one of the foremost genius of statistics. This gentleman made a countless invaluable contribution to statistics. He termed this chi-square test, that is one sample chi-square test, as test of goodness of fit. A goodness of fit is a statistical term. It's a broad topic in statistics and we need more time to study it elaborately. But we need to understand what precisely this goodness of fit is for our purpose. For example, if you buy a new shirt or a pair of jeans, we want to make sure that you find it good or useful to fit. Otherwise, the shirt or jeans are of no use. The same is in statistics. If you need to make sure that the data you have is a good fit with your model, we can do this by creating a comparison between observation and expectations. Observation means the data that we are collected through questionnaires, and our expectation is what we intended to conclude through the model of study. Here it is the one sample chi-square test. Using the one sample chi-square test, we are going to test the equality between observed data and expected data. That is, the variance between observed and expected. A goodness of fit test in general refers to measuring how well do the observed data correspond to the fitted model or how it is fit within our model. Goodness of fit testing is an important element of any analysis. That is the importance of chi-square test in research analysis. The goodness of fit test is a statistical hypothesis test to see how well the sample data fit a distribution from a population with a normal distribution. The next thing is that normally one sample chi-square test is used to test the null hypothesis. Again, another statistical term, the hypothesis. A hypothesis can be defined as a tentative explanation of the research problem or a possible outcome of a research, or we can say an educated guess about the research outcome. The test the null hypothesis is that there is no significance between observed, that is the actual data that we are going to collect through our questionnaires, and the expected frequencies. That means we are test whether any difference between the data that we are collected and what we are expected. The difference between observed and expected frequencies. For understanding more about the hypothesis, visit the link I have given below in the description section. Just click on that link. You can get an idea about the hypothesis. And one sample chi-square test is a non-parametric test. Again, one more term, that is the parametric test and non-parametric test. In statistics, there are two types of tests, that is parametric and non-parametric. If the data you have collected is in the form of well-known distribution, then you can apply a parametric test. Otherwise, you can apply a non-parametric test. So, the non-parametric test is a distribution fit test. We will discuss more the parametric and non-parametric test in coming videos. Now, what are the requirements for conducting a chi-square test? The first thing is that here you need to only consider one variable. That is, here the variable is our mobile phone brand. The second thing is that minimum 2 levels of variables required. The levels or categories of variable means how much category that you are going to consider under a single variable, that is mobile brand. Here we have 4 categories. They are Samsung, OnePlus, Apple and Sony. Like that, you can consider a lot of categories under a single variable. The third requirement is that n number of levels or categories possible. You need minimum 2 levels. We can use different levels or different categories under the single variable. Now we move to the assumptions of chi-square test. The first assumption is that one categorical variable required to conduct a one-sample chi-square test. The variable that we are considering for study should be in categorical format. That category may be dichotomous, nominal, or ordinal. The example of dichotomous is gender, for example, male or female. Next one is, are you politically exposed? Yes or no. Are you married? Yes or no. These are called dichotomous variable. The nominal variable is a pure categorical variable. For example, your profession, your educational qualifications. More than 2 options we can given. That is called nominal variable. Ordinal variable is very familiar. That is the Likert scale data that we are considered as ordinal variables. But in Likert scale here, that Likert scale options are considered as categorical variable. The second assumption is that independence of observations. Again, one more statistical term, independence of observation. That you should have independence of observation, which means that there is no relationship between any of the cases. That means the participants. The statistical assumption of independence of observation states that all participants in a sample are only counted once. If the respondents are answering to same question 2 times, we are only counted as 1. Here we are considering only 1 response from 1 participant. That is, independence of observations make sure that each participant's variance affects the overall analysis just once. That is a gem of that assumption. And the third assumption is that the groups of categorical variables must be mutually exclusive. Mutually exclusive, another statistical step. And it is derived from the theory of probability. For example, if you consider turning left and turning right are mutually exclusive. That means you cannot do both at the same time. Another example is tossing a coin. Heads and tails are mutually exclusive because it never happens simultaneously. So, for example, what is your gender? A respondent never answer male as well as female. He can only answer one thing. That is called mutually exclusive. The fourth one is that, this is a technical assumption, there must be at least 5 expected frequencies in each group. That means here we have 4 groups. The respondent to one group should be minimum 5. It's a technical assumption. Therefore, check out the first 3 assumptions. Whether it is categorical variable, independence of observations are there, and the variables must be mutually exclusive. If these 3 assumptions are met, then you can check the 4th one. Now, we move to the procedure for chi-square test. The first procedure is set null and alternative hypothesis. Another statistical term, hypothesis. This is not the time for explaining the hypothesis in detail. I have already given a link below. You can refer that link to understand what is hypothesis. A null hypothesis may be there is no difference in proportion of consumers preferring different brands of smartphones. Simply we can say that the observed data, that means the data that we are collected through questionnaires, are near to the expected observations. That is, actual and expected are something same. That means there is no difference in the proportion of consumers preferring different brands of smartphones. We have already discussed about the purpose of chi-square test is to test the null hypothesis. So this will be the null. There is no difference. The alternative hypothesis is something different, just opposite of the null hypothesis. That is, there is a significant difference in the proportion of consumers preferring different brands of smartphone. That is, the observed data is significantly different. That means the data collected through questionnaires are significantly different from our expectation. So, set the null and alternative hypothesis. The second procedure is cast the data in a tabular form. The data means the data that we are collected. That is the observed data or actual data. So, data collected through questionnaires, we tabulate it. Here in this example, we are tabulated the data later using Microsoft Excel. The next is calculate the expected frequencies for each of the categories. That means actual that we have with us, that's the data that we are collected through questionnaires. Next, we are going to calculate the expected frequencies. We are going to apply an equation later in Microsoft Excel. The next procedure is calculate the chi-square value. For calculating one sample chi-square value, we need to apply an equation that we will do later. And after finding the chi-square value, then we are going to interpret the result and make a decision. So this is a procedure of chi-square test. Now we discuss what is chi-square test and what is the requirements of conducting chi-square test and what are the assumptions and what's the procedure for conducting chi-square test. Now we move to the Microsoft Excel. Open Excel. We need to record the responses of the respondents. We need two columns. The first column respondent ID and the second column is the brand preference. Just format that column. Then centralize it. Now just enter the respondent IDs. Here I am entering 10. Now instead of entering the brand name in full in the response column, we need to codify it. That is 1, 2, 3, 4. The one represents the Apple, second Samsung, and the third represents Sony. The fourth one is OnePlus. Instead of entering the full name of the brand, we enter that code. If you prefer to Apple, just enter 1. Then 2 to Samsung. Here I just randomly enter 10 preferences. So 1, 3, 2, 4, that is the preferences by the respondents. Now just you enter 300 responses. In this example, I am going to consider 300 responses. That means our sample size is 300. Be quick. Now I am ready. I have entered all the responses of 300 respondents. Record all the 300 responses. Now we need to find out the frequency of each brands. So how much prefer to Apple, how much prefer to Samsung, how much prefer to Sony and OnePlus. That is the observed frequency. So here we give the number, then brand, observed frequency or actual frequency. So how much opt Apple for their preferred mobile brand? Apply the equation, count if, we can count, select the range, response column as considered as a range, then comma, what we are going to count, that is 1. Before closing the parenthesis, freeze the range column. Press F4. Now we freeze it. Then press Enter key. Now we find out 77. Then drag it down. We will get the frequencies of each brands. 77 people prefer to Apple, 99 people prefer to Samsung, 66 people prefer to Sony, and 58 people refers to OnePlus. Now we need to check the equation of chi-square test. Here is the equation of chi-square test. K sigma equal to 1, O minus E whole square divided by E. O means observed frequencies that we have already in the table. E is the expected frequency. Now we are going to calculate the expected frequencies. Expected. Then centralize it and bold it. Okay. So for calculating the expected, we need to calculate the total number of respondents. That is called N. That is our sample size. It is 300, obviously. The next thing, how much category that we have, how much levels, that is considered as K, represented by small k. Apple, Samsung, Sony, OnePlus. Number of levels, we can say it K. That is 4. 4. Yes. Now, the N is 300 and the K is 4. We need to calculate the expected. Actually, expected is if the null hypothesis is true, the preference to Apple, Samsung, Sony and OnePlus are equal here. There is no difference. So that is our expectation. How we can calculate it? Very simple. Divide the N by K. That is, divide 300 by 4. Press enter key. It is 75. If Apple is 75, Samsung 75, Sony 75 and OnePlus 75, that is our expectation. So copy to remaining columns. Now, then expected frequencies are equal. 75, 75, 75, 75. Then total it. Obviously it will be 300. With 300. Now here you need to check it out. We have 2 columns. That is observed frequency. That's the actual preference of consumers that we are collected. Then what we are expecting, that the null is we are expecting, that is there is no difference. If there is no difference, what will be the frequency? Out of 300, 75, 75, 75, 75, there is no difference. Here in this table, the observed is different from expected. We are going to test this difference is significant or not. That's the purpose of chi-square test. Definitely here we can see a difference in this table, but we are going to test it whether this difference is statistically significant or not. That's the purpose of testing the hypothesis using chi-square equation. Now, observed are there, expected are there. Now we need to find out the difference between observed and expected. That is O minus E. The next column is O minus E. Equal to 77 minus 75. That is 2. Then drag it down. You can see the difference. It might have some negative values are there. No problem. Now, the next column is square it off. You will square the difference. O minus E whole square. Yes. We can the square of that O minus E column equal. Then the power symbol, you can see the symbol in combination with the top row numerical value 6. Power symbol, then 2. We'll get 4. Now select that column and drag it down. Now we will get the square of all the columns of O minus E. Centralize it. Now we need to find out the O minus E whole square divided by E, that is expected frequency. 75. O minus E whole square divided by E. That is O minus E whole square, that is this column, and expected is this column. So record as E is expected. This is a O, that is observed. So add O here. Now we are to apply the equation of O minus E whole square divided by E, then 4 divided by 75. Then drag it down. Yes. Reduce the decimal place to 2. Yes. Then total it. Sum this column. Auto sum. Now we will get 12.67. So this is a chi-square value. We solve the equation. 12.67. Instead of creating this much columns, you can find out this particular value directly applying in a single equation. So I am explaining in detail for understanding the procedure. Now, if you expertise this, you can apply the equation directly. Look how we can do this. Equal O minus C, that is observed, that is 77. Select that column. Then minus expected 75. Then close the bracket. Then power symbol, square, then 2. Top, then divided by again 75, that is expected. Press enter. You see we'll get the same value. Drag it down, reduce the decimal place to 2. Now see, the two columns are same. So this equation we can apply directly. By avoiding, you can avoid all the columns, creation of all the columns. This is a chi-square value. Now this is our null hypothesis and this is our alternative hypothesis. We need to check whether the null is true or alternative is true. That means if you are going to, whether the null is accepted or alternative is accepted. For this purpose, we have two methods you can apply for testing hypothesis. One is the critical value approach and second is the p-value approach. Both are same, but normally in research purpose, we are applying p-value method. For the academic projects for graduate or postgraduate level, you can follow critical value as well as p-value. So in this video, I am going to explain both these techniques, how we can test hypothesis using critical value as well as p-value method. For critical value method, we need two things more, that is the degree of freedom and level of significance. Again, two important terms, that is degree of freedom and level of significance. First one is the degree of freedom. In statistics, the degree of freedom indicates the number of independent values that can vary in an analysis without breaking any constraints. So degree of freedom are the number of independent values that a statistical analysis can estimate. You can also think of it as the number of values that are free to vary as we estimate the parameters. The method of finding the degree of freedom is very simple. Count the number of categories or levels under a single variable minus 1. Here we have k minus 1. So equation of degree of freedom is k minus 1. That is 4 minus 1 to 3. The degree of freedom is 3. The next thing is that the level of significance. Another very, very important terms in all hypothesis testing. The significance level shows how likely a pattern in your data is due to chance. Means you are collected the data from the respondents and you plot it in a tabulation form and convert them into graph. You will get a pattern. Check whether this pattern is due to chance or by random. This is expressed by the significance level. The most common level of significance is 0.95. That means the findings has a 95% chance of being true. But this value also used in a misleading way. There is no statistical package will show you 95% or 0.95. Instead, it will show you as 0.05. That means 1 minus 0.95 or 100 minus 95. Very simple. So here our level of significance is 0.05. Meaning of this 0.05 is that the finding has a 5% chance of being not true, which is a converse of a 95% chance of being true. Actually, this is a representation of the type 1 error. There are two types of errors, that is type 1 and type 2, that we will discuss later in coming videos. So this is controlled by the researcher. Researcher can set the level of significance according to his convenience. So here we are going to set the level of significance at 0.05, and this 0.05 is commonly used level of significance, or you can set it 0.01 or 0.005, that according to your study. But commonly used level of significance is 0.05, means a 5% chance of not being true. That is 95% of our study is going to be true. Here the degree of freedom is 3 and level of significance is 0.05. Now we need to check the chi-square critical value. For this purpose, you need to check the chi-square distribution table. Here is the chi-square distribution table. Now you check. I have already given a link below in the description. Click that particular link and you can download this chi-square distribution table. You look at this table, you see degree of freedom. The first column, this is the level of significance. You can see the different level of significance. So we need to find out degree of freedom at 3 here and from the top 0.05. Select, this is the value, 7.81. You see, from left hand side, you select the degree of freedom and top you can select the level of significance, 7.81. This is a chi-square critical value. Now we have three values, degree of freedom, level of significance, and based on these two, we confirmed the chi-square critical value, that is 7.81. Without table, you can find out the critical value using a Excel function, that is ChiSquare.inv.rt. This is a function you can find out the critical value without testing this table. So the first is the probability value, that is 0.05. Second is the degree of freedom. Two parameters. Close the bracket, press enter key. The same as the critical value. You got it? Use it. 7.81. You see? You can find out the chi-square critical value by applying the equation ChiSquare.inv.rt. Two parameters you need to enter into the function. First one is the level of significance. The second one is the degree of freedom. You will get the critical value. Or we can refer the table. Now we are going to check how we can test the hypothesis using the critical value method. So before that, we are going through the hypothesis, the null and alternative. The null is there is no difference in the proportion of consumer preferring different brands of smartphones. That means the proportion of difference of 4 smartphone brands are 75 each. That is the expected. Expected supported by the null hypothesis. That is 75, 75, 75, 75. Now, the alternative. There is significant difference in the proportion of consumers preferring different brands of smartphones. That means the proportion of 4 smartphone brands are different or which are not equal to 75 each. We have already seen that there's a difference in our tabulation table. But that difference is due to by chance or random. We need to check whether this difference is significant or not. For this, we are going to check using critical value method. In this approach, we are comparing test statistics and critical value. The test statistic means the chi-square test result. This is a chi-square distribution table. The speciality of chi-square distribution table is that the pattern of distribution is changing according to the degree of freedom. Suppose this is a chi-square distribution. First step is that look up the critical value. That is 7.81. That is we have already find it out through the table. We are also find it out through the Excel equation. So critical value 7.81. So I am recording it here. Here is the critical value. The critical value divide the distribution into two parts. The first one, the left side of the critical value is the acceptance region and the right side is considered as the rejection region. The second is that calculate the test statistics. That we have already calculated. The chi-square value is 12.67. You just record the 12.67 in this graph. It will definitely after 7.81. Here it is the 12.67 in the graph. Now compare them. That is where it reside. That means the chi-square value reside in the acceptance region or in the rejection region. If it is acceptance region, then do not reject null hypothesis. That is, the assumption of null hypothesis is true. If it reside in the rejection region, that is the right hand side of the critical value, that is the rejection region, so reject the null hypothesis. Here in this example, 12.67 is the right hand side of 7.81 or it is greater than 7.81. So our interpretation is that the null hypothesis is rejected or reject the null hypothesis. So we reject the null hypothesis and we are accepting the alternative hypothesis. So this is a method of critical value approach. Next, we are going to check how we can test the hypothesis using Pvalue method. So just return to Excel, open the Excel sheet. We need to find out the p-value. What exactly a p-value? A p represents the probability. The p-value is probability value. A p-value is used to hypothesis testing to help you support or reject the null hypothesis. The p-value is the evidence against the null hypothesis. The smaller the p-value, the stronger the evidence that you should reject the null hypothesis. P-value are expressed as decimals, although it may be easier to understand what they are if you convert them into percentage. For example, a p-value of 0.0254 is 2.54%. This means there is a 2.54% chance your result could be random. That is happened by chance. That is not good. On the other hand, a larger p-value, for example 0.9, means 90%, means your result have a 90% probability of being completely random and not due to anything in your experiment. That is not due to chance. Therefore, the smaller the p-value, the more important significance your result. So this is the easiest way to check the null hypothesis, and this is commonly used in research papers and thesis. Now we are going to find out the p-value. We can apply an equation equal to ChiSQ chi-square dot test. You can see two arguments are there. Actual region, you select the full actual region. Here is the actual, comma, the full expected. Close the bracket, enter key. So you will get it. You round it up 0.0542. So this is the p-value. If you know the p-value, you can directly get the chi-square value. There's an equation in Excel to find out the chi-square value using p-value. Here it is. So chi-square value equal to another important function that we have already applied it, equal to ChiSQ dot inv dot rt, the same function that we are applied. The probability here, the probability should be the p-value. Yeah. Before we are applying it, the probability value is the level of significance. Instead, here we are given the p-value as a probability value, comma, the degree of freedom, the same. Close the bracket, press enter key. You see the same chi-square value, 12.67. You see? So instead of that tabulation method, you can directly get the chi-square value through the p-value. So chi-square equation as well as p-value equation. Now we go to the next section, how we can test the hypothesis using p-value method. Hypothesis using p-value approach. In p-value approach, we are comparing the p-value and level of significance, that is alpha. If the p-value less than or equal to alpha, then reject the null hypothesis. If the p-value greater than alpha, then fails to reject the null hypothesis. So this is a golden principle of p-value approach. Now check here, our p-value is 0.0054, alpha value is 0.05 that we have already set. Here the p-value is less than equal to alpha. So we can say reject the null hypothesis because there is strong evidence for significant difference in proportion of consumers preferring different brands of smartphones. This is our conclusion. So this is called the p-value approach. This is used in most of the research papers and your research theses. Now we move to how to report and interpret this research result. First of all, how we can report it for a project purpose, that is your academic projects. First, you display the tabulation table like this. First column brand, second column observed frequency, third column expected frequency, and the final row shows the total number of observations, that is called n. Now this is a style of interpretation of our findings. Since the calculated chi-square value of 12.67 is greater than the critical chi-square value of 7.81, there is a strong evidence to reject the null hypothesis of no difference. Therefore, it is concluded that the preference for different brands of smartphone is differently different for the consumers. If we look at the actual frequencies in the data table, we see that the preferences for brand Samsung is greatest and the least for the brand OnePlus. This is a statement that you need to shown in your project as the interpretation and the style of reporting. Now goes to check how we can report this for a research paper. Normally in research papers, we are following an APA style of reporting, or we can say APA format. APA stands for American Psychological Association. This is a worldwide accepted format of reporting in research papers. Here I am going to explain how we can report in APA format. So for this purpose, first of all, you need to depict the table like this. First column, the variable, that is smartphone brand. Second column, the chi-square value. Here it is 12.75. The third column, p-value. That's it. Now we are going to explain what is the APA format for chi-square test. Here it is. A test was conducted for the difference in the proportion of consumers preferring different brands of smartphones. Second sentence, chi-square within bracket. First you place the degree of freedom. The next you place the n, that is the total number of observations, close the bracket, equal to 12.67. That is our chi-square value. Semicolon, then state p less than 0.05. Here it is p is less than 0.05. If it is opposite, you state that p greater than 0.05. Here in our example, the p-value is less than 0.05. Here, there is a statistically significant difference in the proportion of consumers preferring different brands of smartphones. This is the standardized reporting style under APA format. Now, our problem is over. I hope you enjoy this video. If it is helpful for you, share this video to your friends and colleagues. Please subscribe my channel and press on that bell icon for latest updates. See you on next video. Thank you.